is Flash Isaac, and I'm a teacher from the future. This episode, we shall be looking at preliminary tests. A substance which appears white when cold and yellow when hot is likely to be dashed. What do you say? When you hear things like this, they are under preliminary tests. A substance which when cold appears white and when hot appears yellow. Ion present is zinc ion, or the compound is a zinc oxide. In practical chemistry, we have quantitative analysis and volumetric analysis. Volumetric analysis is used to calculate the amount of substance present. For example, in titration, what we are dealing with is volumetric analysis. You see the volume of acid present, the volume of base present, the number of moles present. All these are volumes. But qualitative analysis helps us to identify the ions, the elements or compounds that are present using various tests. And we have two types of tests. We have the preliminary test and the confirmatory test. The preliminary test is to know what is suspected. For example, you are in your house, then you hear on your door. What is suspected is a human being knocking, right? What you suspect may not actually be what you confirm. You go out, you open your door, you discover that it is a dog. You're like, seriously? So, the confirmation is different from what? The preliminary test or what we suspect. But other times, you open the door, you actually see a human being. Most of the time, what you suspect or the confirmatory test or the preliminary test usually becomes the confirmatory test. But you can't always conclude. Remember, it is not over until it is over. Now, when it comes to preliminary test, we have different types of tests. Appearance test. Based on how something appears, you can tell the compound or the ion present. The flame test. When this substance or compound bonds, what color of flame does it produce? Then, that is another preliminary test. Then action of heat. When you heat this substance, what does it change to? What color does it produce? What happens when heated? So, we shall look at all these as we can see on the board. Let's start with the appearance test. A green colored salt is likely to be ion 2 salt. When you are given a salt and you are told that the color of the salt is green, that is ion 2 salt. Color of ion 2 salt is green. Then a white colorless salt. There are many ions present on the probable salt when they are white colorless. Examples are calcium ions, lead ion, ammonium ion, aluminium ion, zinc ion salt. So any salt containing calcium ion, lead ion, ammonium ion, aluminium ion, and zinc ion will be colorless salt, white colorless, white or colorless salt. And any salt that has the smell of ammonia will likely be ammonium salt. Smell of ammonia, ammonium salt. Any salt that has the smell of sulfur, know that tetraoxosulfate 4 is suspected. SO3 2- is suspected. And when a salt has the smell of hydrogen sulfide, know that sulfide is present. These are appearance tests. Now let's look at flame test. For color of flames, when a substance or a compound burns with blue or livid blue flame, know that lead ion is present. It burns with blue or livid blue flames. Jam we say, if a substance burns with lilac flame or violet color, it is potassium ion. The color of flame for potassium ion is lilac or violet color. And brick red is calcium ion. When you hear it burns with a brick red color, that is calcium ion, brick red. And bluish green is copper 2 ion. Copper 2 ion, bluish green. Then Golden yellow is sodium ion. Sodium ion bonds with golden yellow, or when a compound bonds giving us a golden yellow flame, we know that sodium ion is present. Then light green flame, barium ion is present, Ba2 plus. Now let's see the action of heat. When ammonia is heated, no, when a substance is heated and you are told that ammonium gas was evolved, that means ammonium ion is present. If hydrogen gas is evolved when heated, know that NO3 ion is present. If NO2 is evolved when heated, know that NO3 minus is present. When SO2 gas is evolved, know that SO3 minus is present. When carbon dioxide gas is evolved, know that there is a presence or suspect, or we are suspecting CO3 2 minus or HCO3 minus. And when hydrogen sulfide gas is evolved, we are suspecting the presence of sulfur ion, S2 minus. And this is color change when heated. When a substance which appears yellow when cooled becomes, when the substance which appears white when cooled becomes yellow when hot, we are suspecting zinc ion, and we are suspecting the compound to be zinc oxide. A compound which appears yellow when cooled and reddish brown when hot is likely going to be lead ion, PbO, lead oxide. A compound which appears yellow when cooled and reddish brown when hot, there is presence of Pb2 plus. Ladies and gentlemen, all these are preliminary tests to look for what is being suspected. In the next episode, cations are positive ions. Remember, metals generally ionize by electron loss. Ions are simply atoms that possess electric charge. You see this? This is Al3 plus. You cannot call this aluminium. Meanwhile, when you have something like this, Al, we can call this aluminium. This is aluminium atom. Anytime an atom loses electron, it will become a positive ion. When an atom gains electron, it will become a negative ion. So generally, metals will readily give out electron. So their ions are positive. This is why we say metals ionize by electron loss. While non-metals generally, example chlorine, oxygen, they will gain electrons to form their own ion. At that case, they become negatively charged. As such, we say non-metals ionize by electron gain. Don't learn to forget, because this knowledge will carry us to metals and non-metals. To test for positive ions, we use sodium hydroxide and dilute ammonia. These are the two materials or the two compounds we use to test for cations. Which of the following are used to test for cations? They are sodium hydroxide and dilute ammonia. This is how we use them. First, you drop them in drops. You put them in drops. Later, you add them in excess. So, sodium hydroxide in drops and in excess, then dilute ammonia in drops and in excess. The ammonia is aqueous. Aqueous means it is in solution, most time in water. So this ammonia is dissolved in water. So aqueous ammonia in drops and aqueous ammonia in excess. Now look at this carefully. When you have an ion which form white precipitate when you add sodium hydroxide in drops, then when you add sodium hydroxide in excess, you notice that this precipitate is soluble in excess sodium hydroxide. You simply say that lead ion is present, Pb2 plus. Now aluminium ion forms white precipitate with drop of sodium hydroxide, and this precipitate is soluble in excess sodium hydroxide. Zinc ion forms white precipitate in sodium hydroxide drops, and in excess sodium hydroxide, this precipitate is soluble. For lead ions, aluminum ion, zinc ion, they give us the same result. They all form white precipitate, which is soluble in excess sodium hydroxide. Now, look at this. Calcium ion forms white precipitate. However, the precipitate of calcium ion is insoluble in excess sodium hydroxide. This is what distinguishes calcium ion from lead ion, aluminum ion, and zinc ion. Look at something else. You may be wondering, why is it that lead ion, aluminum ion, and zinc ion are all soluble in excess sodium hydroxide? This is because they are amphoteric. This is a jam question. Sodium, zinc ion, aluminum ion, and lead ion are soluble in excess sodium hydroxide. Why? It is because they are amphoteric. Don't ask me what amphoteric means, because this is a series and we've dealt with amphoteric over and over again. Amphoteric oxide, this and that, even in acid, bases, and salts. Now going down, we have ion 2 and ion 3 ion. When you drop sodium hydroxide in ion 2 ion, you will have a dirty green precipitate. When you drop sodium hydroxide in ion 3 ion, you will get a reddish brown precipitate. Both precipitates are insoluble in excess sodium hydroxide. So both ion 2 and ion 3, they give us insoluble precipitate. Then copper 2 plus will give us blue precipitate. This blue is insoluble, while ammonium ion don't form precipitate at all. So you don't really need to cram this. What you should know is that lead, aluminum, and zinc ion, they all form white precipitate and they are soluble because they are amphoteric. Then calcium forms white precipitate, but it is insoluble. In fact, apart from lead, aluminum, and zinc, every other ones are insoluble. Then for color, the first four are white, ion 2 dirty green, ion 3 reddish brown, copper 2 plus is blue. So these are confirmatory tests for these cat ions. Now let's see test with aqueous ammonia. This is test with sodium hydroxide. With aqueous ammonia in drops, lead will form white precipitate. You see, they are repeating what they did here. Lead, aluminum, and zinc, they will also form white precipitate with aqueous ammonia in drops. But a problem comes in. Only zinc ion will be insoluble. In fact, of all the tests with aqueous ammonia in drops and excess, only zinc ion and copper ion are soluble in excess aqueous ammonia. Why? This is because they form complex ions with ammonia. Why are zinc and copper 2 plus soluble in excess aqueous ammonia? This is because they form complex ions. Now, zinc will give us white precipitate, lead will give us white precipitate, aluminum will give us white precipitate. This lead ion and aluminum ion, they both give us white precipitate, and the two precipitates are insoluble in excess aqueous ammonia. So how do we distinguish between lead ion and aluminum ion? We have two ways to distinguish between them. One, lead ion will give us yellow precipitate when you add potassium iodide, but aluminum will not. The same lead will form white precipitate with concentrated hydrochloric acid. However, aluminum will not form precipitate. So this is a test to differentiate these two guys. Calcium ion here form white precipitate, which is insoluble. But when you test with aqueous ammonia in drops, calcium ion will not even form precipitate at all. No precipitate is detected. Then ion 2 will give you dirty green precipitate. Ion 3, reddish brown precipitate. Exactly the same thing you have here. That is what you have here for the color. Even copper ion will also give you blue precipitate. The colors are the same except for calcium ion, which does not form precipitate with aqueous ammonia in drops. Then for solubility, they are all insoluble except for zinc ion and copper ion. Ladies and gentlemen, let's look at test for anions, negative ions. Now, when it comes to the test for gases, the test for oxygen and H2O is that or are they rekindle a glowing splint. But the difference is that while oxygen can rekindle a brightly glowing splint and even a splint that is dimming, H2O can only rekindle a brightly glowing splint and it has sweet smell. Meanwhile, oxygen is odorless. The test for hydrogen gas is that it burns with a pale blue flame and it makes a pop sound. The test for ammonia is that it has a pungent smell, while hydrogen sulfide H2S has a rotten egg smell. From here, we shall be looking at test for other gases and test for anions. And like I said, after this, we shall look at confirmatory tests, making use of these other compounds mentioned. Now, when it comes to the action of dilute HCl, which of the following gases is detected? Or which of the following ion is detected? For example, they will tell you that dilute hydrochloric acid is added to a solid, to a solution, or to an ion, or to whatever. Then, effervescence occurs with the evolution of a colorless, odorless gas which turns lime water milky. You see the keyword, turns lime water milky. So what gas is that, and what ion do you think is present? This is a hot cake jam question. Anytime you hear that dilute hydrochloric acid is added to something and you see colorless, odorless gas which turns lime water milky, the gas there is carbon dioxide. Carbon dioxide is the gas which turns lime water milky. Now, for the gas present, it is carbon dioxide. The ions present will be CO3 ion and HCO3 ion. For the gas present, CO2 is detected. For the ions, CO3 2- and HCO3 2- are present. When you hear effervescence, it means evolution of gas bubble. That is effervescence. Then JAM will give you another essay. Dilute HCl was added to blah 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 blah. Then a colorless gas with a pungent smell evolves. The gas turns blue litmus paper red and turns acidified potassium permanganate from purple to colorless with no yellow deposit. What gas is detected? The gas is simply sulfur dioxide gas, and the ions present will be SO3 2-. Anytime the gas like CO2 is suspected, the ions present will be CO3 2-. When the gas SO2 is suspected, the anion present will be SO3 2-. Then you hear another essay. Dilute HCl was added to this. Then there was evolution of colorless gas with rotten egg smell. The gas turns blue litmus paper red and lead ethanoate paper black. Immediately you hear rotten egg smell. Then hydrogen sulfide gas should come to your mind. It is all these keywords you should look at. Turns lime water milky, rotten egg smell, that is H2S, the gas present. And the anion present is simply S2-, sulfur ion. These are the hot cake tests for anions using dilute HCl. Now, using conc H2SO4, you are told that conc H2SO4 was added to this and heated. There was evolution of colorless gas with an irritating smell. Now you see that keyword, irritating smell. The gas turns blue litmus paper red and it fumes in moist air. The gas forms dense white film with the lid of conch ammonia bottle. Which gas is present and which ion is present? Immediately you see irritating smell, know that we are talking of HCl gas, not hydrochloric acid but hydrogen chloride. In gaseous state, HCl is hydrogen chloride. But if you see HCl aqueous, AQ, that is hydrochloric acid. In this case, the gas present is HCl and the ion present in HCl is Cl minus, chloride ion. Then you'll be told that conch H2SO4 plus manganese oxide plus heat was added to blah 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 blah. Now this is the observation. There's a liberation of greenish yellow gas with a pungent smell. Now you see the keyword, pungent smell, like that of jig, that is like that of bleach. This turns litmus paper red and bleaches it. It turns starch iodide paper blue black. What is present? That is simply chlorine gas, and the ion present is also chloride ion or chlorine ion. Then you'll be told conch H2SO4 plus copper tunis plus heat was added to blah 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 blah, or conch H2SO4 was added, then copper tunis, then heat, whatever. But when you hear the observation, the evolution of reddish brown gas with a pungent smell, the gas turns blue litmus red and starch iodide paper brown. Now look at this. For the first one, greenish yellow. For the second one, reddish brown. Greenish yellow is chlorine gas, reddish brown is NO2, nitrogen 4 oxide gas, and the ion present is NO3 2 minus. When you see NO2, the ion present will be NO3 minus. When you see CO2, ion present is CO3 2 minus. When you see SO2, ion present is SO3 2 minus. So, ladies and gentlemen, let's look at confirmatory test for anions. When you have a test solution, you add aqueous silver nitrate, then you add dilute HNO3, then you add aqueous ammonia in excess. Then you get the following observation. You notice that it forms white precipitate with silver nitrate. Then this precipitate is insoluble in dilute HNO3, and you see that this precipitate dissolves in excess aqueous ammonia. What do you think is present? The inference are 1. When you add silver nitrate to a solution and white precipitate is formed, CO3 2 minus or Cl minus or SO2 minus are suspected. By the time it doesn't dissolve, then Cl2 minus is present. If you now add excess aqueous ammonia and the precipitate dissolves in excess, therefore Cl minus is confirmed. This is confirmatory test for Cl minus. Now, if you have a solution, you add barium chloride, aqueous, and then you add dilute HCl. If at the point of adding barium chloride to a solution, white precipitate is formed, the following are the inference. SO4 2 minus, SO3 2 minus, S2 minus, CO3 2 minus are all suspected. If you add dilute HCl, if this precipitate is insoluble in excess dilute HCl, then SO4 2 minus is present. If it is soluble in excess dilute HCl, then SO3 2 minus is present. And let's look at the brown ring test. Brown ring test is simply adding to the test solution, freshly prepared FeSO4 and conc H2SO4. Carefully pour down the size of a fluted test tube. If you do this and you discover that a brown ring is formed at the junction between the two layers of the liquid, then NO3 is present. This is brown ring test. In a brand new test, the FeSO4 must be freshly prepared to avoid oxidation. And the brown ring is as a result of the presence of FeSO4.NO. This is what forms the brown ring. Ladies and gentlemen, test for cations, test for anions, and test for gases. Thanks for watching your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos. And don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.